we're going to go ahead and just start off with a review of the Pythagorean theorem. And what I really want to stress to you is this is a problem in your book on page 398. So I'm on page 398. And it is problem number 4. And it's a real life example. And this was all, we didn't touch much on 7.3. We're going to. It's just real life examples using the Pythagorean theorem. So it says that you're painting the roof of a shed. You're going to place the base of the ladder 12 feet from the shed. How long does the ladder need to be to reach the roof of the shed? So what we can see here is that they drew a picture. That's going to be my first hint. If they give you all these words but don't give you a picture to go with it, let's draw it. The second thing we know is that they show us that it is a 90-degree angle. Because of our 90-degree angle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. We have to have a right triangle in order to use this. Hopefully you can see the triangle. I'm outlining it in red. And the next thing we need to identify is I always try to figure out what is C. Well, in this case, we don't know what C is. That's actually what we're finding. Diagonal from the 90 degrees will always be your C. So let's plug our numbers in and see what we get. 12 squared plus 35 squared equals C squared. When we do our math, 12 times 12 I know is 144. I have to grab a calculator for the 35. It's going to be a large number. 35 squared means 35 times 35, which is 1225. And that equals C squared. We're going to add those together. And when I add them together, I get 1369. And remember, that's what C squared equals, because that's our formula. So the inverse, when we're solving equations, the inverse of squaring a number is to take the square root. Whatever we do to one side of our equation, we want to do to the other. The y behind this is because my square root and my squared cancel out. And I have C equals. And let's figure out here. What is the square root of 1369? 37. So what does that 37 mean? It says, how long does the ladder need to be? That's the ladder. So we need our ladder to be 37, and this would be feet, in order to reach the house. So Pythagorean theorem, able to use real life examples. We need to be able to draw the picture. Like we could, if they gave us all these words, could we just sketch a shed real quick and try to locate where all the numbers go? We're going to do more practice with this in class. Let's go ahead and jump into 7.4 notes though. If we take a look at 7.4, so this is notes for 7.4, and I love this Explore It. And I am on page 401. This Explore It goes with example 1, so we're actually not going to do example 1. It says Thomas and Jim are outside the haunted castle ride and want to get to the clown tent in time for the next show. So we want to find this distance. First it says, how can we represent the starred locations on the coordinate grid? Well, we got to find those. Here's one star location. Here's the other star location. How are we going to represent that? Well, what I would do and how I'm looking at this is this point right here would be 0, 0. So if I was going to put my starred locations on the grid, I'll do different colors here. My blue starred location would be over 1, up 3. So I'm going to go over 1 and up 3. I'm going to put that dot. And my red starred location would be over 1, 2, 3, 4, and up 1. So those would be my starred locations on this grid, this map. Okay. Now, if we want to know this distance, can't count boxes because we're cutting through boxes. So we don't know if we really have a whole box or not. If we want to know this distance, can you visualize, can you see where you could maybe make a right triangle? I see a right triangle. I see the right triangle just like this. And because we can create that right triangle with my grid lines, we can find that diagonal with the Pythagorean theorem. So we need to count here and see this, my side length on the bottom is going to be 3. My side length on the, from top to bottom on the y-axis is going to be a 2. So since I counted those whole squares, and you can see I'll draw my triangle up above on this grid as well. We can see that this is 1, 2, 3, and 1, 2. This is our right angle. We know that because we're given grid lines. We now can use the Pythagorean theorem. What are we finding? Well, we're finding our C in this situation. So we have a squared plus b squared equals c squared. We know that if we want to get to this, we want to get to the clown tent in time for the next show, if we wanted to walk from this top part and we go down 2 blocks and over 3 blocks, we know we've traveled a total of 5 blocks. Well, let's see what happens if we just go straight, cutting through. So if I put 2 squared plus 3 squared equals c squared, I'm going to change colors, that's hard to see. 2 squared would be 4, 3 squared would be 9. Add them up. And remember that 13 equals c squared. The inverse is to take the square root. And when we take the square root of 13, we get 3.61 is C. So with that being said, if we wanted to walk, like I said, the blocks, we could go 5 blocks to get there, the 2 and then the 3, or we can see that our fastest path would be going straight from the haunted castle ride to the clown tent, which would be 3.61 blocks. So we take off a block in almost a half. Let's go ahead and jump into our example. I am now on the bottom of page 402, and here we can see that they just want us to make that right triangle. So if we count if we make my right triangle here, remember you have to have a right triangle in order to use the Pythagorean theorem. We know that this would be 2 and this would be 2. So their question is how can you find the distance between A and B, straight between A and B? Well, we're looking for C. Identify that right angle. So we can plug these numbers into the Pythagorean theorem. A squared plus B squared equals C squared. 2 squared plus 2 squared equals C squared. Plug all of our numbers in. 4 plus 4 is 8. But that's C squared. Remember, the inverse of squaring a number is taking the square root. And when I take the square root of 8, I get 2.83. So it's about 2.83 units. So again, we are creating right triangles with our grid lines in order to use the Pythagorean theorem. We can only use the Pythagorean theorem if we have right triangles. This is example 2, and there's just a couple things I want to point out. I know they've done it for you here. First of all, you have to be careful with this triangle because it goes all the way across the y-axis. So again, I would just count the boxes. Okay, this side length here would be 5, and this side length would be 3. Okay. And so then you can find your diagonal by using the Pythagorean theorem. The other word I want to talk about here is that they talk about the perimeter. Think about a fence around a yard. The perimeter means the distance around a shape. So we're talking the distance around a shape. And so that total distance would be you add all sides. So in this example, they want us to find the perimeter, which means we're going to add all sides of this triangle. Well, we already know the 3 and the 5, but we have to find the diagonal, which we know we can use the Pythagorean theorem because we have a right triangle to find our unknown C. And that's what they did. So they went through on step 2, they found C. Step 3, in order to find perimeter and add all sides, they added the 5, the 3, and the 5.83. And they found the perimeter of this triangle is 13.83 units. Last example that I want to point out is looking at this triangle here. I want you to go straight to step 3. There's no right angle. You would have to make a right angle here. They drew this dotted line in order to create the right angle. Okay, so remember we can only use the Pythagorean theorem when we have a right triangle. So this is all still Pythagorean theorem and still looking at real life examples of how to solve those. We're going to go ahead and do some practice when we come back together in class. Have a great day.